Hello. In this tutorial, I will look at how to calculate the expected return and the risk measures for three different random variables, which I will call stock A, stock B, and stock C. And so we'll use those two values to compare the profitability and the risk associated with each of the stocks. And you can notice that stock A has the dividends that are exactly the same as in the previous example. So this will hopefully help you see how that computation unveils because you've seen it already. And then stock B is something new. Stock C is going to be our benchmark case where that distribution is going to be kind of restricted. You see it only has one value and the associated probability is 1. So basically stock C is going to pay 250 for sure, but we're also going to see what it means for a sure thing in terms of expected return and the risk associated with it. But first, let's return to stock A and calculate the expected return of stock A. Remember, to do so, we need to take the weighted average of each possible realization, each possible dividend multiplied by the corresponding probability. So what I'm going to do first is I'm going to type in equal, which tells Excel to use a formula, and then I'm going to say 100. So I'm pressing on 100, and I'm typing in the star, which is the sign for multiplication. Then I'm going to click on 0.1, and so it interpreted it as the value in the cell is going to be the product of the value in D3 and D4. So it's going to calculate this product for me. It's going to equal to 10. Now I need to apply the same formula for the remaining three realizations of stock A. So I'm going to find the bottom right corner of the cell. So you can see how the plus sign appears when your cursor hits the bottom right corner. And I'm just going to highlight the whole range to which I would like the formula to be applied. And so it automatically recalculates it. So 80 is going to be 200 times 0.4, 120 is 300 times 0.4, and so on. Finally, to calculate the expected value, I need to add up these numbers together. So in this blue cell, I'm going to type in equal sum, and I'm going to open the bracket, and I'm going to use the cursor to highlight all the cells that I want to be added up together, and then I just need to close the bracket. There we go. That gives you an expected value of 250 for stock A, just like we calculated in the previous video. Let's do the same for stock B. Equal sign 50 times 0.2, enter, highlight the whole range, and then equal sum, add up the values for the whole range. Gives you 250 as well. And finally, for the third stock, there is just one possible realization multiplied by the probability of 1. So that should give you 250. And so obviously, the expected value has to be 250 as well. I'm just going to type it in. So you can see that in these three different distributions, three different possible future dividends for three different stocks, the expected value is going to be exactly the same, although the three distributions are completely different. So that shouldn't surprise you. It's just showing you that the distributions are centered around the same value of 250. Now we need to calculate the risk that corresponds to each stock. So the first step in calculating the risk is to calculate the deviation between the realizations of the stock and the expected value of the stock. So I'm going to take the next row, type in equal, then press on 100 because this is the realization. And from that 100, I need to subtract 250. And I'm going to type in enter, and I should get 150. Now, one thing that I need to do, if you're just going to apply the formula for the whole range, you will get correct numbers because as you're moving from 100 to 200 to 300 to 400, it's also going to move from 250 to the next cell to the right, and those three cells to the right of 250 all have no contents, and so they will be treated as 0. So in order to make sure that in every case it is exactly 250 that is subtracted, I'm going to go back to the formula in the cell, and I'm going to put a $sign in front of H5, which is a placeholder for 250. In this way, when I extend the formula for the whole range, cell D3 will be replaced with the next cell in the row, cell H5 will stay the same, and so 250 will be subtracted all the time. Let's see how this works out. Negative 150, apply for the whole range, negative 50, 50, and 150, just like we expect. So this works out right. Next step, we need to square the deviation. So I'm going to type in equal, press on the deviation, type in hat, and 2. That puts it to the power of 2, that is squares it. We get 22.5, and then 2,500, 2,500, and another 22,500. Second to final step. We need to calculate the expected square deviation. So we need to take equal, take our deviation value squared, and multiply it by the corresponding probability. Hit enter, get 2250, and then you get 1000, 1000, and 2250 again. And now for our standard deviation, we need to find the sum, but then we also need to take the square root of that sum. So I'm going to do it in reverse order. I'm going to type equal, and then SQRT, which is the square root, and then I'm going to put in the brackets, and that square root will be taken off the sum of the 4 values, like this. Square root of the sum of the 4 values. And that gives me a value of 80.62. Again, just like we calculated in the previous video. So the standard deviation is $80. Let's perform the same calculation for stock B. Starting with the deviation, so that equals 50 minus expected value. Now put the $sign in front of the expected value. Hit enter. Okay, looks correct. Next, square the deviation. Next, weigh the square deviation by the probability. And finally, say that you want the square root of the sum of the weighted square deviations. And that gives you a value of 148.32. So you can see that the value of the standard deviation for stock B is higher than the value of the standard deviation of stock A. And you can interpret it as follows. So both stocks promise an expected dividend of 250, but stock A has its realizations closer on average to 250 than stock B does. So stock A should be considered less risky and stock B should be considered more risky. Finally, let's do the calculations for stock C. We need to do 250 minus 250. That gives me a deviation of 0. So that square deviation is actually going to be 0 as well. And so weighted square deviation is going to be, again, 0. And thus the standard deviation is going to be 0 as well. So how should we interpret what's going on with stock C? Stock C pays $250 for sure. So there is no risk associated with stock C. So I'm just going to emphasize that here. Standard deviation of 0 stands for no risk at all. So the smaller the standard deviation, the smaller the risk associated with a uncertain outcome. The higher the standard deviation on the other case, the higher is the spread of the realizations of the random variable around its mean, and thus higher the risk. So in this example, all 3 stocks have the same expected return of 250. Stock C has 0 standard deviation, no risk at all. Stock B has the highest standard deviation, and stock A is somewhere in the middle. Thus, we now have a tool to compare risks of stocks with similar expected returns. Thank you.